Welcome back. This video is page MC23, also known as questions 43 and 44. So let's get started. The answer you're looking for is C and D. So let's take a look. Which of these, if you got these wrong, C and D, let's figure out what notes we need to take if we got these wrong. So the first question states, a magazine has about 1.6 million subscribers. About 600,000 are women, 900,000 are men, 30% of the women read the ad, 50% of the men read the ad. A random sample of 100 subscribers was taken. What should we expect? So I've been doing a lot of these today. I'm going to do another two-way table because it is two pieces of categorical data. So you're either a man or a woman for the purpose of this example, and you either read it or you did not read it. So it makes it pretty easy to sort our information here. Now we definitely know the grand total. The grand total is 1.62 million. So that's exactly the number of people that are our subscribers. And they told us the women and the men. Voila. Now, we have to figure out if we can read the question and fill in some blanks here. So we know of these women, 30% read it. So I'm just going to write that in here. 30%, so 0.30 times 6,400, so excuse me, 64,000. And of the men, 0.50, that one's a little bit easier, 980,000. So mathematically in my box, I think it makes sense. Half of these guys read it, and 30% of these ladies read it. So I'm going to fill that in with another color because I had to do math. So 0.5 times 980,000 is 490 and 192. There we go. So using a little math, that's how many men read it. That's how many women actually read it. I can pretty easily figure out the total of everybody that read it by adding those two numbers. And I get 682,000. So out of the total subscribers, these are the people that read it. And it looks like that's what they want me to calculate. What is expected from the sample of people that subscribe? If I took 100 people, how many of them would I expect read it? So that's how many out of that many. So the probability of reading it would equal the amount that read it over the total amount of subscribers, and I get 0.42. So 42% of my subscribers. So mu x bar is n times p. So this is my formula from the formula sheet. If I know n and I know the probability, then I can figure out what I expect. So 42%, this one you can kind of do in your head, but if n is 100, 42% of 100 is actually 42 people, and that's why that answer is 42. Next question. Now I wrote 980. This is also one of these types of questions that go just straight at the question. They don't try to trick you. It says the manufacturer of a light bulb claims the reliability is 98%. Then they define what 98% is. So they're saying reliability means the proportion of non-defective items that are produced. If a company claims, if their claims are correct, what would we expect to have of non-defective light bulbs in a random sample? Okay, so we know that mu is equal to mu x bar. So whatever we get from a sample should equal the total population, and that's what they're saying. So mu x bar is n times p. Mu x bar is n times p. So if I know how many samples I have, which is 1,000, all I need to know is my probability. Well, they told me my probability. They said the probability is 98% of the time. So that would be 980. Thank you for joining us.